Hi, my name is Susan Gudenkopf. I'm with the Customer Advocacy Organization within VMware, which is a part of our Global Support Services team. First of all, thank you so much for coming to this and attending VMworld. This is huge. I've been to all of the VMworlds, and this is huge compared to where we started. So thank you for that and for your business. Secondly, we're going to talk today, Peter's going to talk about performance best practices. And what this is called, we call this an example of our Customer Support Day events. I don't know if anybody's been to one before, but we have regional support day events where we bring our experts from the technical support office out into the field, and we have customers come in and talk to our experts about various topics for a day of technical training, basically. And then we'll do an Ask the Expert session where you can ask any questions you want about anything technical, and it's a really great way to get to meet our experts, talk to them about the stuff that they work with you guys on day in and day out. So if you have one of those in your area, I highly recommend trying to go to it. Peter's got a slide on that, and it'll show you the website you can check out to see if there's one in your area. And we do about 16 of those a year, so we definitely can't hit every area. We also do a virtual Customer Support Day event, which is brand new this year, and I'm responsible for overseeing the strategy of those events. So please attend, come to the Virtual Support Day event. That's probably going to be in the November timeframe. And you can get that from going to vmware.com/go/customer support days. And like I said, Peter's got the link in here. So without further ado, I'd like to introduce Peter Boone, one of our escalation engineers from our, your Burlington office? Burlington support office. So thank you very much, and thank you for coming. Go ahead.
Thanks. Hi, everyone. How are you today? Thanks. So I'm Peter Boone. I'm an escalation engineer from Burlington, Ontario, and I'm on the systems management team. We deal with performance, anything to do with the vSphere suite itself, like vCenter. I deal with Heartbeat, ESX, ESXi. Pretty much anything that doesn't fall under the networking or storage categories is something I deal with on a day-to-day basis. So GSS, if you're not aware, we're a global support organization under VMware. We've got offices around the globe for our Follow the Sun policy so that you can get your critical support whenever you need it. And again, I'm from Burlington, Canada. And as mentioned, this is part of our customer support days. So definitely go to this website and put an interest for your area. And as we get more interest in those areas, we will fly out there and provide presentations such as these and other content that people vote on. So this presentation, performance is a very big topic to discuss. Bring out a notepad and take any questions that you have, write them down, write down the slide numbers, and approach me after the presentation if possible, and we'll talk. And if we run out of time here, I'll be in the VMware booth for any other time that I'm not here presenting. So just come look for me, and I'll be glad to talk about your particular situation and environment. So in GSS, we do get a lot of performance questions, and often the case comes in saying, my VMware is running slow, I don't know what to do, things are not the way they were a year ago, or users are complaining about this. We need to really define where to look, where do we start, and how do we drill down to that solution and the root cause of the problem if we need to. We're going to explore some of the most common things that we see in cases in terms of CPU and memory and storage and networking, and a lot of the solutions for those cases, how to avoid the situation in the first place, and how to solve problems that you may already be experiencing. There's a methodology to follow depending on what the situation is. From a very high-level generic standpoint, these are some of the questions that we'd like to ask. And if at all possible, we want to get the most detailed answer we can. The most important question here is, how do we know when we're done? Because a performance problem, you can continually chase a performance issue, and you may never hit that target that you're looking for. You may be hitting the limits of your hardware. It's hard to know exactly when to stop and when we know we have reached that solution. So in this presentation, we're going to talk a little bit about benchmarking and tools. We're going to look into the best practices and different troubleshooting things that we look into for each of the four food groups, as we call it at GSS. That's CPU, memory, networking, and storage. So benchmarking and tools. Benchmarking is very, very important because it gives you consistent, reproducible results. We need to get a number. We need to quantize exactly what we're looking for. Prior to deploying your application, you should benchmark it in your environment and make sure that it's achieving what you're looking for. If possible, it's sometimes relevant to benchmark on a physical system and then compare that to the virtual one and make sure that you can rule that out prior to calling us a year later saying that, oh, it must be because it's virtual that there's a performance problem. Most of the times, it's not the physical virtual difference that is causing that performance problem. And again, always stay quantitative. It's not really useful to hear things like, oh, it's just slower than it was before. We need to really know, well, how much slower is it than it was before? What numbers did you come up with before that you're seeing now that it just doesn't add up? Always benchmark at the application layer. That's going to try to reproduce the best results on your specific application. So a SQL server, you want to be simulating that random disk I/O. You want to make sure that you're using the cache of the system memory. If you're benchmarking something like disk throughput for a SQL server, that might give you a good top-end number, but it's not going to simulate the actual use of that application. Isolate variables and benchmark the optimum situation before going into deployment. So that also comes back to trying it on a physical system first. See what numbers you get. Put it on a host on its own before it goes into your main production cluster. And how does it perform when it's on its own? And understand dependencies. A web server is going to have major human factor involved. You need to simulate those clicks. You need to simulate the operations that the users are doing on that web application. Other food groups can come into account as well that we may not even think about. I had a case a couple months back where we were looking at a Linux machine that it was trying to do an FTP transfer. And oddly enough, they noticed when they bumped the memory of this machine up to 8 gigabytes, the FTP transfer speeds dropped significantly low, like 5 kilobytes a second, versus when the virtual machine had 4 gigs of memory, it was performing fantastically, pulling 600 kilobytes a second. Major performance issue, and the question was, well, why is the virtual memory on this VM affecting the network throughput? Very head-scratcher type of question. So it turned out it was a memory limit. This VM was cloned from a template that had a 4 gig memory limit on it for some reason. When they bumped it up, the transfer was utilizing a buffer in kernel memory that just was not getting all the memory that it wanted to. Major performance impact just from that alone. But you could chase it as a network issue all you want. You could spend weeks and weeks. You may never come to a solution unless you look at the bigger picture. Compare apples to apples is also very, very important. We often get cases where one virtual machine on an AMD cluster versus the same virtual machine on an Intel cluster with both of them are 2.6 gigahertz. Why is one faster than the other? When you drill into it, CPU cache comes into consideration here. The architecture of that CPU, which generation is it? What kind of memory is that host using? So always keep that big picture in mind. Fantastic tool for monitoring your environment and determining problems maybe before they start is vCenter Operations. If you haven't looked at this already, it's a fantastic tool, and we do have a demo of it on our website. Definitely check this out. It looks at all the resources it can in your cluster, even right down to the application level with agents you install in the VMs. So for example, a web server, you could monitor the hits. vCenter Operations will look for abnormal traffic. I'll show you a picture of that in the next slide here. But it learns what the normal patterns are for each virtual machine in terms of its disk, memory, CPU, networking. And it will alert you when something is out of the norm. And that's usually the start of some kind of performance problem that you may not even notice until maybe a month later when things are just showing up as a lot worse in your environment. With vCenter Operations, you can go back a month and see, okay, well, what has changed in the usage patterns? Is something different? Is something new? What are we missing? And that is a fantastic tool for really drilling down to what a performance problem may be caused by. So in this screenshot here, this is web hits for a specific virtual machine. The line here shows what the hits actually are, and the gray box is showing you what is considered the norm for that time period. There's 7 or 8 different algorithms that it's looking at to determine what is normal, and it gives you this nice little picture here. And you can see right over here, we've got the red and a whole bunch of web hits that are just out of the ordinary. So, I mean, this might not be a performance problem, but this could indicate a change in user behavior, a change in the way your applications are being utilized. It's important to understand that and understand when it's happening and how it may affect this individual application, as well as the other virtual machines that are sharing your resources. ESX top. This is the de facto standard for any performance case, anything you need to look at in terms of performance. ESX top can tell you what's going on. It might not tell you what the problem is, and it's very important to understand what all the different metrics mean. In ESX top, there's a lot of misinterpretation about all the different fields that you can see in here. Very useful because we can use it to capture snapshots. It's kind of difficult to troubleshoot a case when the issue is only happening at 3 a.m. every day and no one's in the environment. So we use ESX top and take a snapshot every 5 seconds over the course of 12 hours. Then we can send that over to support, and my guys can take a look at it and try to see, okay, what exactly was going on in that host. Every 5 seconds, we have a snapshot for the entire system's performance, and it can greatly help us drill down to what the problem is. The vSphere client gets all of its performance data straight out of ESX top. So what you see in both of them is exactly the same, but you just have to keep in mind that the way it's presented can be a little bit different. So CPU ready is a very popular one. In the vSphere client, it shows up in milliseconds versus ESX top, it shows up as a percentage. It's very important to interpret that correctly, especially when we're looking at past month data where every metric on the past month graph is rolled into a half-an-hour time period. Of course, when you add the CPU ready for that individual processor over the course of a 30-minute period, in milliseconds it's going to look big, but once you do the math, it might not actually be a problem at all. We're going to dive right into memory here. This is one of the biggest areas of questions that we get, and I'm going to overview a lot of background of the way hosts manage their memory, how it works, and how you can take advantage of that in your environment. And it might be a review for a lot of people, but it's very important to have a good understanding of how it works, to understand what your virtual machines are doing and how they are getting their memory. So VRAM is not necessarily physical RAM. That's a very common misconception. The virtual machine's allocated RAM plus the overhead that VM needs equals the maximum possible physical memory that VM can consume. Whether it's going to get that memory from a physical chunk of RAM or from other memory sharing techniques depends on the host configuration, resource pool, shares, limits, reservations, whether there's a demand for that memory or not. A little bit about overhead, often mislooked when we're talking about capacity planning. This is from the vSphere 5 Resource Management Guide, and it's the maximum overhead that a virtual machine can consume. And you can see it scales up a little bit. This table was a lot more dramatic in 4.x, where a VM with 8 CPUs and 16 gigs of memory would take up maybe 700 megs of overhead, possibly. Depending on your CPU's memory management and virtualization features, these numbers will be different. But this is the maximum possible for different configurations. And it's very important to keep in mind that every VM will have its own overhead. So, memory management techniques. These will occur when the host is under contention, or if there's a limit set on the resource pool or the virtual machine itself. The 4 techniques are transparent page sharing, ballooning, compression, and swapping. Compression and swapping kind of go hand in hand. We'll talk about that next. So, transparent page sharing is the idea where you have identical pages of memory mapping to one individual physical page of memory. So, if you look at the RAM chip down here, without transparent page sharing, you've got a lot of repeated pages. With transparent page sharing, we can just map that to one page. When you have a host with 20 virtual machines all running Windows 2008 R2, there's going to be a lot of memory in common there. So automatically, transparent page sharing is saving tons of memory for you. This is all done with very, very minimal overhead in the background, nothing you need to configure. Right out of the box, transparent page sharing works. Works between VMs, identical pages in 2 separate VMs, and within one individual VM if it's not being very smart about its memory usage. This helps reclaim pages. The next one is ballooning. This is a very big topic because it's misunderstood a lot. And to overview, ballooning is the concept of when a host needs memory, it can request the balloon driver inside the guest to inflate. What that means is it will just start consuming pages inside the guest operating system. And Windows or Linux will see that higher memory usage and become a little bit smarter about how it's allocating its own memory internally. the host knows that any ballooned pages don't have to map to any physical memory at all. So it's a great way to get memory back from VMs that aren't using it. When the balloon wants to deflate, again, the host just requests that the VM deflates that memory, and the balloon driver will shrink inside. That memory is returned to the VM, and you have physical pages again. Compression is used when the host has to resort to swapping. If there's any pages in memory that have a 50% compression ratio, if we can identify 2 of those pages or more, we'll start putting them into the compression cache on the host. The benefit of this is you don't have to swap it. So when the virtual machine needs that memory again, it can get it right out of the physical RAM rather than spending that 1,000-fold extra time going to the disk to get those pages back. And swapping. We're talking here about host-level swapping rather than your guest OS level swapping. For every virtual machine that you power on, you'll notice you'll have a vswap file for all the unreserved memory of that VM. And if you don't have enough space on your data store, you just can't power on that VM. You'll get a nice error about that. And the whole idea here is that if the host needs memory very quickly on the fly, if the balloon is not getting memory back fast enough and we can't identify we can't identify identical pages, we're going to start swapping it right away. Just start dumping pages to disk. And the host has an idea of which pages are hot and which ones are cold. That is, which ones are being used most by the guest, and it will try to use cold pages as much as possible. Dump it to the disk, and let's get that physical memory back because someone else needs it or there's a limit on that VM. So the concept is very simple. Take that page, dump it to disk. Major performance impact for this if that virtual machine needs pages that have been swapped, though. Physical memory is thousands of times faster than disk cache, even with SSDs. So how can we tell where a virtual machine is getting its memory from? Right in the vSphere client, if you go to the resource allocation tab, you get this nice, pretty picture. Paints a nice memory map for you. This virtual machine here, we've got 4 gigs of private memory, and we can see about 2 gigs has already come from transparent page sharing. So great, nothing wrong with this VM. This looks good. Active memory here is about 1 gig, and active memory is how much memory that VM is actually touching and using for that given time period. Now this picture is a little bit different. We're looking at a resource pool here now. At the bottom, the limit is set to unlimited. But why do we have swapping and compression and ballooning going on here? Well, we can speculate and say maybe that host is under a lot of pressure. It's also possible that the individual VMs within this pool are under limits, or maybe there's child pools with limits on them. And what we can see here is 3.2 gigabytes is already coming from transparent page sharing. Great, that's very good. But we also have 2 gigs of swapping taking place here. Could be a problem if those individual VMs need that memory. 2.2 gigs has been claimed from compression, good. And the balloon driver has inflated for a total of 1.5 gigs among all those virtual machines. This might be a performance problem, might not be. We have to drill down into the individual VM where we suspect there is a problem and determine, okay, where is it getting its memory from? Because the host is smart about which VMs it chooses for swapping, which one it chooses for ballooning. The ones that need the memory, it's always going to try to give it that memory. And the VMs that aren't using it, it's going to balloon it, it's going to swap it, and hand that memory over to the other VMs that might actually need it more. So ballooning versus swapping. Ballooning is better than swapping. I can't emphasize enough that when it goes to disk, it's so much slower than going to the physical RAM. Now, ballooning doesn't necessarily mean that there's a problem. It could just mean that that VM is not using that memory. There's an idle memory tax for virtual machines that just are very, very idle. I had a case where we had a Windows XP desktop, and the balloon driver was inflated for about 60% of that VM's memory. And they were calling in saying, well, this is a problem. Why are we seeing all this ballooning? As soon as we logged into that virtual machine, we wanted to look at Task Manager and just see what was going on. As soon as we logged into the VM, that memory started being used, and the balloon driver deflated completely. We looked at the performance charts. That VM had been ballooned for about 3 months. No one had been using it. No one had logged into it. It was just completely idle. So it just goes to show, as soon as the VM wants the memory, it will get it back if it's available. The big benefit of this is the guest OS knows how it's using its memory. We're providing the memory, and that's great, and we don't really know what that memory is being used for. The guest OS, the memory management module inside the operating system kernel, knows what it's doing, knows what applications are active, which ones are not, and it can choose whether it wants to just reduce how much cache it's using, or if it's going to resort to its own page file internally or swap partition for Linux. So the balloon driver is very, very, very beneficial. Always good to have it installed with VMware Tools. And often, if we run into a performance case and we see that the memory management module, the Balloon driver, was not installed with VMware Tools, first thing we're going to say is, let's get that installed and see what happens. Now, some best practices. It's very, very important to right-size your memory. With all these memory management techniques, it's very easy to overcommit memory in your clusters, and that may work perfectly fine for your applications. I mean, obviously, there is an upper limit to how much you can overcommit, but that's okay. If you undercommit memory, you run into a couple of different issues we'll touch on in the next slide. But if all of your VMs are consuming too much memory on the host or their parent resource pool, you're going to see a couple of things happening. Some of the VMs are not going to get physical memory. Ballooning or swapping may start occurring within the VMs itself first. Anything that appears to be pretty idle will balloon. As soon as you're swapping that memory to disk, you're going to see higher disk I/O. And disks are typically the weakest point in any performance case. And all of your VMs are going to slow down as a result. If you have other physical systems that are utilizing that same cluster, their disk I/O may slow down as a result as well. You're just going to see a big increase in that disk I/O. If a VM doesn't have enough virtual memory, we're not going to be able to see this from the vSphere client. The performance charts are not going to know what's going on there. You may see that the active memory is very, very high for that VM, but other than that, there's no alarm to say this VM needs more memory. What we really need to do is log into that VM, look at Task Manager, and see what Task Manager says. Now, that's not always going to be very accurate. Keep in mind things like SQL Server and Exchange Server are going to use all the physical memory they can for disk cache. That's great for performance. Doesn't necessarily indicate that there's a problem. With 2008 and 2008 R2, go to that Resource Monitor button in Task Manager, look at the memory map, see what's actually in use. There's cache and there's buffer space that is being used. Linux has been doing this for many, many, many years, and Microsoft is now doing it in 2008. It's a fantastic thing, but when you see your memories at 87% in Task Manager, that's a good thing. That's healthy. When your memory's at 96% in Task Manager, you're hitting a limit, and that VM probably wants more memory. Did I click ahead here? Yep, I did. So again, the virtual machine is going to start swapping in its own swap file or, page file with Windows or swap partition on Linux. Increased disk traffic, SAN slows down. If this is happening on a large scale, your SAN might not be able to keep up with it. Now on the converse here, if your virtual machine has too much virtual memory, the overhead may be a little bit higher, not as much of an issue in vSphere 5 and 5.1 now. You might have decreased failover capacity if you're using a lot of reservations with high availability. vMotions may take a little bit longer. Your vSwap file is going to be larger while that VM is running, and you may be wasting some resources. But you can see the benefits of this. There's not a performance issue here. There may be a performance impact for your vMotion taking a little bit longer, but that won't affect the virtual machine's performance. Users won't even notice. When we're troubleshooting memory, we need to look for wrong resource allocation, like the network FTP transfer case, for example. As soon as we saw that limit, that resolved it right away. So look for limits. Look for it on the virtual machine, and then start going up the tree. Look at the parent resource pools. Are there any limits there that we may be missing? Custom share values as well. The defaults are normal, high, and low. And if you use a custom value, it's an absolute share value that's not going to change unless you change it. So as you're adding more virtual machines to that resource pool, the other VMs that had that custom share value will need to be adjusted as well. They're not going to get the resources that they need. Ballooning or swapping. Again, remember, ballooning is more of a warning sign. Doesn't necessarily indicate a performance problem. If you're seeing your VMs are ballooning across the whole board, you do have a memory overcommitment issue. But if you're seeing some VMs are ballooning and others aren't, evaluate the shares on those. See if the high, normal, low is performing as you expect. Swapping is a performance problem if you're seeing it over a long period of time. If the host did need those pages on the fly, it'll swap those down, but it doesn't need to put them back into memory until the VM needs it. So you might see a VM still has some memory swaps, even if there's memory available. If you're seeing it a lot or over a long period of time while that VM is actually being used, then there's probably a performance issue. Swapping and paging at the guest operating system level. Again, this is very hard for us to see from the vSphere client, so take a look inside your guest operating systems. If you're noticing a lot of disk I/O taking place for a VM that probably shouldn't have it, there's probably some swapping going on inside the guest. And missing the balloon driver inside the guest is just going to hurt the rest of your environment when that VM does not need its memory. So make sure that that's installed. So best practices when we're talking about memory. Look at the active memory rather than the memory allocation itself. If you're seeing a lot of high memory overcommitment, that's when you're going to see some issues, because all of those VMs want that physical cut of memory, and our hands are tied in terms of what we can do to fix that problem from the software level. You allocate less memory to those VMs or add more hosts to your cluster. The swapping is the last resort that the host will go to, so if you're not seeing the swapping happening, you're probably okay. Let the balloon driver do what it needs to do. Make sure you're right-sizing that guest operating system. Your end users running on a View desktop probably do not need 12 gigs of memory per VM. Some might, most don't. So right-size that memory exactly where it needs to be and keep that capacity available for where it is needed. Ensure there's enough VRAM inside the VMs to cover peak demands. Your VMs doing a maintenance schedule at 2 in the morning are not going to have the same memory demands as during the day when they may be sitting idle. And fully automated DRS. You already know this if you're using vCloud. Use that fully automated DRS cluster. Test if vMotion is working for your VMs and let DRS do those balancing decisions for you. It will recognize a performance problem before it turns into too much. I can't count the number of times that a case has come in where a single host is just having very heavy contention and DRS was on partially automated or manual. And if it was fully automated, the host could have spread that load out before the call was even generated. Avoid using custom shares because that's just going to hurt your individual VMs. And use resource pools. We often see like a high, normal, low resource pool right in the parent cluster. And prioritize your VMs as they need to be prioritized. So the VMs with higher priority will get that memory before the lower priority ones do. And this only comes into account when there's contention on the actual host. If your memory is not over allocated and there's no need to do anything, then the VMs will get their private memory. And that's that. It's as simple as that. Next big one is CPU. As we know, it's the raw processing power of a host or VM. The host provide it, and the cluster itself will provide it. And the VMs will consume it. And resource pools can consume it as well if you're using limits and reservations. It's a timeshare type of thing rather than memory where there's a slice of memory provided. Cores and threads, if you're using hyperthreading, have to be shared between all those virtual processes and the management agents and the drivers and the VM kernel. Fair scheduling of those virtual CPUs and all those management agents is a bit of a challenge from a virtualization level if you really go under the hood. There's hardware interrupts for those VMs. When that network packet comes into the host has some overhead to make sure the packet is delivered to the virtual machine properly. Parallel processing, when we've got a virtual machine with four-way SMP, that's a bit of a scheduling challenge that we've been able to overcome. And I/O, again, it goes back to the interrupts. Anything that the VM wants to do on the physical level is going to generate some CPU overhead. ESX top is often misinterpreted here. We'll talk more about that in some coming slides here. We often get calls in where we're looking at these numbers and we're saying, oh, well, why is that percent weight so high? It's very important to interpret these fields properly. There's a lot of things, and it's hard to memorize, so always look at a reference guide here. A couple of things like percent used is the actual physical CPU usage. And things like turbo features on your processor where it overclocks for a short period of time. You might see percent used is going to go over 100%. Percent sys is the time of processing in the VM kernel. It's a good idea of what overhead is being generated by that virtual machine. Percent run is the CPU scheduler saying, okay, this virtual process is getting this percentage of time in the next cycle to run. Now, percentage weight is it's hard to interpret this one. It's the percentage of time in a blocked or busy wait state. Now, why it's blocked or in a busy wait state can be a number of different things. It might be a CPU limit. It might be the CPU is not available yet, which is kind of like ready time. It might be because of some I/O. Disks are extremely slow compared to the processor. Something we can do is we can take percent weight and subtract the percent idle. And you can estimate your I/O wait times. If you're used to looking in top in Linux, you've got that I/O. The I/O wait value at the top. That calculation is very similar. We have some challenges because we're emulating virtual hardware. We're passing interrupts along from the physical card to the virtual card, so this number is going to vary. Now, performance overhead and utilization. Different workloads will have a different CPU signature, if you will. Calculating the digits of pi is just straight math, and the host can pass those math instructions straight to the processor, process those instructions, and send it back to the VM. Very, very simple. But when we're talking about hardware, let's say a virtual machine is shutting down. The host has to interpret that as the virtual machine shutting down, not the actual host physical machine shutting down. The CPU doesn't know, so there's some overhead involved with privileged instructions. Now, symmetric multi-way processing. This is just simply the concept of having more than one CPU on a system. Symmetric multi-way processing is just a CPU architecture thing. It's not specific to VMware. We're talking about virtual symmetric multi-way processing, and we run into a couple of different challenges. In ESX 3.5 and earlier, if a CPU wanted to run, a virtual CPU rather, all of those virtual processes need to be on that physical CPU at the same time. As of 4.0, we have relaxed co-scheduling. I'll talk a little bit more about that and how it ties into your environment soon. Idle virtual CPUs have a scheduling penalty. It doesn't matter how idle that virtual process is, it still needs that CPU time. It needs to keep up. Operating systems expect that when they want CPU time, they're going to get it. They don't know that they're virtualized. So it's very important for the VM kernel CPU scheduler to make sure everything is getting its share of time. If you have a lot of virtual CPUs that are not being used, there is a scheduling penalty. Because again, it does need that physical time on the processor. And you're just going to be stepping on the toes of other virtual machines that may need that CPU. How many people kind of encounter a CPU-related performance problem in their environment? What kind of things are you chasing? Let's see a raise of hands. CPU issues in your environment. Just a couple. That's kind of the big thing about virtualization is CPUs are often underutilized. If you have looked at physical systems, Task Manager may often be at 5%. It's just not being used. So that's the glory of virtualization, where we can cut that out and share it among different systems. Now, let's back up a little bit. What about memory? How many memory contention issues? A lot more hands going up. And that makes sense, because memory is very easy to overcommit and cut out to a system. So if you have a uniprocessor, uniprocessor virtual machine application, a lot of legacy applications were not programmed to take advantage of multi-CPU systems. We only started seeing multi-core systems in the early 2000s. This is a new thing. If you're running older legacy systems, they probably don't need more than one virtual CPU. So don't give it that extra virtual CPU. So the CPU scheduling, as of 4.x, the virtual machine wants CPU time. This guy has 4 virtual CPUs, goes to the CPU scheduler, and it gets 4 physical CPUs. We've got another VM here with 2. It gets 2. And another VM gets its 2. And also keep in mind there's the management agents, there's drivers, there's the VM kernel overhead, and all of those things will need to be scheduled on a physical CPU as well. Now what happens when we introduce another virtual machine here? 4 processors. It wants some CPU time. Goes to the virtual CPU scheduler. It now has to decide which processor am I going to deschedule so that this VM can get its share of time. And it's chosen these 2. They're blocked for a moment, and this virtual machine gets its CPU time. Now with 4.x, we can overcommit CPUs a little bit more comfortably because we have relaxed co-scheduling. When virtual machine 1 here has 2 virtual CPUs that need some CPU time, and the other 2 are maybe a little bit idle and they can wait a little bit. The CPU scheduler can do that. There's a problem here that, again, those virtual CPUs cannot be too far out of sync or your kernel will just crash. The operating system does not expect that. So that's going back to the right sizing your virtual CPUs. CPU ready time. We get a lot of questions about this in support. How many people here have filed a case with GSS in regards to ready time with their CPUs? Oh, fantastic. No hands. Okay. It's very important to interpret this correctly and accurately. It's the percentage of time that a virtual process wanted time on the physical CPU but had to wait for it. Now, why did it have to wait for that CPU time? A lot of different things come into play here. If the CPU is being used very actively, very high usage, and you're seeing high ready times, that's a problem. An idle virtual CPU may see higher ready times, perfectly healthy because it didn't need the CPU. This chart down here, right from the vSphere client, we've got a VM here with about 300 megahertz of usage across 2 vCPUs, each vCPU. Very, very low, and as a result, we can see ready time is a little bit high here, 50 milliseconds and 20 milliseconds for that VM. Is that a problem? Probably not. Why is the usage so low if it's a problem? You may not even notice any problem inside that guest operating system. Throw a CPU benchmark on there, you'll see the CPU usage will spike up and the ready time will go down. It's getting the CPU that it wants. Perfect. NUMA nodes, fairly new concept, especially when we're talking about virtualization. NUMA nodes is the concept of which memory banks a physical processor owns. The memory management unit on the processor can address its specific banks of memory. If you look at a physical motherboard with more than one processor on it, you can see that those banks are physically closer to specific sockets. That's a NUMA node. In today's processors, today's 12-core processors, for example, will be split up into 2 NUMA nodes, where 6 cores are one NUMA node, 6 cores are the other NUMA node, all within one die. And we need to consider how these virtual machines are using these NUMA nodes. How do these NUMA nodes come into play in your environment? Now, the whole idea of a NUMA node, it's not a physical structure as much of telling the operating system which physical processors belong to which physical memory banks so that it knows where performance is best. A process running on one NUMA node can cross over to the other NUMA node, no problem, but there's a slight performance impact for that because it has to travel across a bus rather than having that fast, high-speed link straight to the memory. Your results may vary, depends on the motherboard, depends on the CPU. That performance impact is very hard to measure, but it depends on what the application is. The VM kernel, when it realizes that you're running a NUMA-aware system, it's going to try its best to keep those virtual processes local to the virtual machine's memory. That's called the home node. Now we run into some problems here when your memory or CPUs are too big to fit in one NUMA node, and that's where we might see some performance issues depending on what the VM is trying to do. Manual CPU affinity will definitely affect this. If you've accidentally spread out 4 virtual CPUs across 4 different NUMA nodes, the whole memory is still on one of those nodes. So you've got a scheduling constraint there that the host just can't do anything to help with. So don't use CPU affinity. It's good for troubleshooting, but not much else. And fully automated DRS won't allow you to use CPU affinity at all. Excellent. Inside the host, it will automatically balance NUMA nodes as needed. If you power on a lot of different VMs, they're going to be spread out. And if that usage changes and another NUMA node is less utilized than another and it's starting to see a performance impact, it will just do an internal migration. That memory will move from one NUMA node to the other, and that's that, done. Virtual machines with more vCPUs than fit in a NUMA node may see the decreased performance, as mentioned. So it's important to understand what your physical hardware can do and allocating your virtual machines accordingly. Now in 5.0 we have virtual NUMA, where the larger virtual machines will expose NUMA architecture to the operating system. Not all operating systems will, well, the application specifically can take advantage of this. Something like SQL Server, though, will recognize that these processes have quick access to this memory, and it will take advantage of that. When we're troubleshooting CPU issues, first thing to look at is overallocation. Often we see hyperthreading is the biggest factor where the capacity planning for that specific cluster doubled the CPU count, and that's just not accurate. Hyperthreading in best case scenarios will give you 30% performance boost if the application is properly using it. So keep in mind, hyperthreading does not double your CPU capacity. Using CPU limits or too many reservations we can often see. You'll have artificial limits if your reservations are taking up more space than unreserved CPU available. VMs are not going to be able to get the CPU time they want. And expecting the same consolidation ratios with different workloads. And that's the idea of environments new to virtualization are going to start with the easy VMs, maybe a domain controller, maybe a couple of desktops, simple stuff. These days, people are getting a lot more comfortable with virtualization, and we're seeing business critical applications being virtualized far more often. those applications have far different demands than your end user that's just trying to use Outlook. So it's very important to understand the differences in the VMs that have been virtualized. And always compare apples to apples. Going back to an example case I had, I'll give you a different one where we were comparing a physical system to a virtual system. The physical system was a laptop. I think it was a Core i7, and the physical system was also a Xeon 5600, I believe, series. And we were wondering, okay, why is this virtual machine performing so much worse in my virtual environment than in my physical environment? We isolated the variables. We got every other VM off that host. Benchmarks were just showing a difference of 1,000 in a CPU benchmark. When we looked into it further, look into the processors. One processor has 4 megs of cache. The other processor has 8 megs of cache. Major, major difference there. And another one was the laptop had hyperthreading, and the host didn't support hyperthreading. Right away, we were seeing the differences there. We weren't comparing apples to apples. We tried. I mean, they were both Intel. He did everything he could. But in the end, it just wasn't the same. So best practices. Always right-size your virtual CPUs. Too many virtual CPUs, scheduling constraints. Not enough virtual CPUs and your applications may suffer. But consider, does your application actually need that 8 CPUs at 2 in the morning? A backup appliance that may generate a lot of CPU traffic early morning, it's okay for that to be at 100%. That's okay. The difference between having those extra CPUs and not may be 5 minutes in the backup time. Test it out and see what you get. Because during the day, that backup appliance is not using those CPUs. You've got scheduling constraints for the other VMs. Try to keep your heavy hitters separated. Fully automated DRS will do this for you. It'll recognize when VMs have high demands and just vMotion them. Problem solved. If you need to, use anti-affinity rules. If you know that you have an active-active SQL cluster that's very, very busy, separate them. Use the DRS anti-affinity rule so that they never end up on the same host. And again, fully automated DRS cluster. Make sure vMotion works. Use those resource pools and avoid custom shares. Common theme in CPU and memory performance cases. Next area here is storage. And we have a number of good storage presentations here today and this whole week. Storage is something that's challenging for VMware because a lot of it is not VMware. Let's take a look into why. First of all, when we're troubleshooting storage, we want to look at ESX top counters or the performance charts. This is what we specifically look at. Typically, we go straight to the adapter, and we're looking at latency, we're looking at throughput, and we're looking at IOPS. A high D average indicates a problem outside of the host. That's your device average, and it's not something that we really have control over. It could be for a number of different reasons. Every environment varies, so it's very hard to say exactly where your problem is. High K average is inside the VM kernel. Might be because of storage I/O control impeding some limits. Might be a driver issue. It might be the queue is full or set too low. The host is going to abort a SCSI command that takes more than 5 seconds to complete. And that aborted command will just be repeated again and might just thrash your storage processor. So high latency is obviously a very good indicator of a problem. Benchmarking, it's important to do it inside the guest operating system. IOmeter is a fantastic tool for that. And what we can see here is total I/O per second. We got throughput, and we can see some IOPS and how much CPU overhead that is actually creating in performing that benchmark. From the guest OS level, it's very important to keep in mind that there's going to be that CPU utilization overhead as throughput goes up. And this tool is also great because you can simulate different types of traffic. A straight read of your whole disk from start to finish is going to go significantly faster than random 4K I/O. So keep in mind what the benchmark is doing. And this is also why it's very important to use vendor-provided application benchmarks that will simulate the type of disk I/O the application typically performs. And there's typically different profiles for the type of SQL server you're using, or if it's an Exchange benchmark, how many users your environment will be serving. Storage I/O control was introduced in 4.0, I think. Allows the use of shares per VMDK, and throttling will occur when your storage I/O passes a certain threshold. By default, it's 50 milliseconds, and as soon as vCenter recognizes that a specific host has gone over that 50 milliseconds, it will start throttling back any VMDKs on that data store. And the hosts will just hold back on their I/O until that latency does come back down again. This can help avoid thrashing your storage processors. You'll see that as k-average in the ESX top metrics. And if you're using your storage across multiple vCenters, this is not effective at all. You have to make sure that one vCenter is monitoring one set of data stores, otherwise this is completely out the window. Storage DRS introduced in vSphere 5.0. This allows you to cluster your data stores, makes management significantly easier, lets you use anti-affinity rules. Often, as we all know, we've got a 2 terabyte limit on data stores, so you will have probably 10 different OS data stores. Cluster them all together and let Storage I/O Control take a look and see if there's some balancing things that can be done, depending on how those VMs are using those LUNs. It monitors for latency as well as capacity. So again, it's just like DRS on the host level for CPU and memory. It's not effective if your SAN is already doing this for you. It can be, so you have to make sure that it's supported on our HCL, and you can get some extra details on how to configure storage DRS to work properly with your multi-tier array. When we're troubleshooting storage, first thing we want to look at is snapshots. If you don't know how snapshots work, when you have a snapshot on a VM, it's a Delta file. The base disk remains unchanged, goes read-only, and all I/O goes to the Delta file first. If it's not found in the Delta file, it goes to the parent disk. If you have a snapshot chain of maybe 30 snapshots, that's going to have a major performance impact. Consider your I/O patterns. And I always go back to the example of the 2 a.m. virus scan or the 2 a.m. Backup schedule versus the 9 a.m. all your users logging into Exchange at the same time. Is the problem that you're seeing happening during one of these peak times, or is it happening randomly? We really need to know how that storage is being used if we want to effectively figure out where the problem is. Always consult your array vendor. I started off by saying that it's typically not a VMware issue. Check the vendor. They know that you're using your array with VMware, and they know how to use it best. So make sure that you're using the right pathing algorithm. Make sure that if there's any agents that need to be installed on your host, that they're present. Very, very important. So best practices. Use different tiers of storage. If you're using SSDs, use that for the swap files. Use that for your databases and your Exchange servers. Make sure you have a separate VMDK for that specific VM, so you've separated the operating system, which may be SATA 7200 RPM disks, from the database itself, 15K SCSI disks. Use the Paravirtual SCSI adapter inside your virtual machines, especially important for those high I/O VMs. This is going to reduce CPU overhead for performing that I/O, and it'll give you slightly better throughput. Use path balancing properly, and if you need those plugins, make sure they're installed on the hosts. Round robin is fantastic if your array supports it. So again, this all comes back to the type of array you have. Check with your vendor and make sure that you're okay. And storage DRS with Storage I/O Control will help you identify trends and move things around to balance load. And again, this comes down to how your storage array is utilizing the LUNs underneath the hood. Networking. We typically don't see networking as a bottleneck in a network. For years, we've had gigabit Ethernet. Now we have 10 gig Ethernet, and we're seeing some new challenges, specifically with the way drivers are using CPU. As a 10 gig adapter approaches its limit, we're seeing CPU is going to go up substantially. A couple things about networking. It's important to understand the load balancing algorithms here. We have a lot of misconceptions about how these work. Route based on port ID is the concept of a VM kernel or a virtual adapter is allocated to one physical adapter and only one physical adapter. Unless anything changes that it needs to rebalance that, like a link goes down or you've changed the teaming policy, changed some active adapters, it's going to be on that adapter the whole time. And this is the most friendly, most compatible with any switch because one VM is only showing up in one place. Route based on IP hash is the concept of you have a bundle of maybe 4 physical adapters. We're looking at the source and destination IP address, generating a hash, and routing according to that. And that gives you per connection load balancing. Your physical switch has to support this, otherwise it's just not going to work at all. And we often see cases where a bundle was changed. So your Ether channel was set up for 2 NICs and your host was set up for 4, and we're wondering why some traffic works and some doesn't. Route based on MAC hash, very similar actually to route based on port ID because it's based on the source MAC, and that source MAC is not going to change while the VM is running unless for some reason you are changing it. And route based on NIC load is new in the virtual distributed switch 4.1. It's the concept of the NIC is going to be evaluated for its throughput every 30 seconds, and if a NIC is recognized as having too high of traffic and approaching its utilization limit, that traffic will be routed to another NIC that's lower utilized. Again, this is a virtual distributed switch feature as of VDS 4.1. There's always a probability of those high bandwidth traffic being on the same physical adapter. All of these different routing concepts are different ways to try to tackle that problem. It's hard for the host to predict what your network utilization will be. So our hands are a little bit tied in that regard, and there's a lot of work being done in this area to try to improve it as much as possible, but it's definitely a challenging area. So it's all probability-based. Typically, route based on IP hash tends to give you the best results, but again, all of these algorithms are just looking at a raw number and putting that on one line, and it's not looking at what the throughput is or the size of the packet to decide where that goes. And again, traffic will always stay on the elected uplink until something occurs to tell it otherwise. A route based on IP hash, if the destination source IP address is always the same, it's always going to be on one NIC. When we're troubleshooting network cases, first thing we look at is the counters. Where is that network traffic and who's generating it? Where is it coming from? It just could be that the pathing algorithm is not balancing properly in this situation. Again, 10 gig NICs are going to start using a lot of CPU as they approach their limits, and that's going to be pure overhead on the host. Ensure that your hardware supports TCP segment offloading. I have not seen any hardware that did not support this in the last many, many years, but if you're worried about it, double check. Make sure that the driver and firmware are up to date. Important to make sure they both match. The firmware and the driver go hand in hand. For multi-tiered VM applications, with the VMXNet 3 adapter, you get a 10 gig virtual link to the vSwitch. And even if you have gigabit uplinks on your host, your VMs can still take advantage of that 10 gig switch between each other. So if your VMs are using a lot of network traffic between each other, use an affinity rule to put those VMs on the same host, put them on the same vSwitch, give them VMXNet 3 adapters, and you now have a 10 gig link between those VMs. Fantastically fast, and you don't need to spend all that money on 10 gig uplinks. And if you're using jumbo frames, make sure it is enabled end-to-end. Your switch has to support it, your card has to support it, the VM kernel needs to be aware of it, the vSwitch has to be aware of it, the storage array has to support it. I have had cases where jumbo frames was turned on at the storage array and not on the host, and we had a lot of problems. VMs would not power up, tasks would sit in progress and never finish. It's very, very strange behavior, and the host can't really recognize that those packets are not making it properly. A lot of arrays are going to send iSCSI traffic with the don't fragment flag set, so the packet will never make it back to the host. The switch itself, if it's not configured for the jumbo frames, it will start breaking down those packets for you to an acceptable frame size, and that's generating a lot of extra overhead for your switch. So best practices. Use the VMXNet 3 virtual adapter. Again, this is a para-virtual adapter that doesn't have a physical counterpart. If you're using E1000, the host has to simulate that physical adapter for compatibility inside the guest operating system. VMXNet 3 has less CPU overhead, and it's designed for a virtual environment. And again, you have that 10 gigabit connection to your virtual switch. Make sure the driver and firmware for the physical NIC is up to date. Use network shares with the VDS 4.1. As you approach a contention situation, you can make sure that the traffic that needs high priority gets first call at the physical adapter. iSCSI traffic, very important that it has first pick to keep your storage response time as you expect. And isolate traffic as much as possible. Now these days we've got 10 gig links and the host may only have 2 of them. And versus gigabit links where the host has 8 to 16 different adapters. If you're on gigabit, definitely take advantage of having multiple adapters and separate that traffic. vMotion traffic will saturate a physical adapter instantly. iSCSI traffic, you want to have it responsive and not have to wait in line to be processed by the physical adapter. So if they're isolated, no other traffic can get in the way. And again, use a different vSwitch for that. So a couple things in conclusion here. Understand your environment, inside and out. We need to know what your physical hardware is doing and how your virtual machines are trying to use it. This can be challenging these days. We do get a lot of cases where one department handles the SQL side, another department handles the virtual side, and another department handles the virtual desktops. It definitely makes it challenging, but we really need to know how things are being utilized to effectively troubleshoot and understand where a problem may be coming from and why. As you notice throughout this presentation, you don't need advanced configuration values to tweak your host and get the best performance out of it. Right out of the box, you do have all the memory management. The CPU scheduler is going to do everything it can. In some fringe cases, or as you approach very, very challenging high demand or low latency issues, you may need to tweak some values, and we have lots of white papers that tell you what needs to be done. Fully automated DRS. Let DRS move those VMs for you. Let it recognize where the demands are and what needs to be moved and what doesn't. And pair virtual hardware, such as VMXNet 3, the pair virtual SCSI adapter. These are all designed to make that I/O faster and at less of a cost. So use them as much as possible, especially as you scale your environments up. There's going to be a lot of extra overhead if you're not on pair virtual hardware. When you get the slides here, these are just some important links to take a look at. Communities, very valuable, and our KBs are fantastic. You've probably read a bunch of my KBs without even knowing it. Some more good links here. And that's the presentation. Please make sure you give me some feedback through the polling, and you do get entered into a draw automatically. If anybody has any questions, do feel free to reach out to me, and I'm glad to take a look. Thank you very much.